Good morning, class. I'm Mr. David Ayoro, a teacher of chemistry. Would like to discuss identification of cations. This is a continuation of acid, bases, and salts. So, what's a cation? In our Form 2 lesson, we discussed about atoms. In atoms, we have got ions. And in ions, we have got positively charged ions and negatively charged ions. The positively charged ions are what we call cations. So cations, that is positive ions, can be identified from a solution using precipitation reaction. So what's a precipitate? A precipitate is any insoluble solid which we get from a solution during a chemical reaction. So that process of precipitation can help us identify the positively charged ions. So we can use two chemicals to identify positively charged ions. We can use aqueous ammonia, that's ammonium hydroxide, and we can also use a solution of sodium hydroxide or potassium hydroxide. Those are the chemicals which can be used to identify cations. So you'll be given a procedure in the laboratory. So you'll be given a solution to identify the cation which is inside there. So in the procedure, you'll add 3 to 4 drops of aqueous ammonia to the solution being tested, the test tube, then you add excess. You add excess. So you will get observation. And I have got samples of observation which you can get from a practical question like this one. So the first one, if you get a wet precipitate, then the precipitate is insoluble in excess. A wet precipitate you get after adding 3 to 4 drops, then you add excess. You get that the precipitate does not dissolve. So in our observation, you write wet precipitate insoluble in excess. So the possible ions which will be there will be lead-2 ion or aluminium ion. And look at the spelling for lead-2. The ions must be written properly. Capital P, small b, and 2 positive, and the charges are 2 positive. The same for aluminium. Capital A, small l, and the 3 charges which are positive. So why is the precipitate not insoluble? If you look at our equation, let us start with lead. You know, lead will react with the hydroxides of ammonia to form lead-2 hydroxide. So this is the ionic equation. The lead-2 hydroxide formed will not be soluble in excess ammonia solution. The reason why it is not insoluble is that it does not form a complex ion. It will only be possible. It will only be soluble if a complex ion is formed. The same with aluminium. Aluminium, which is from the test solution, reacts with the hydroxide ion to form aluminum hydroxide. This aluminum hydroxide is insoluble, and it is a white precipitate. So the precipitate here is insoluble in excess. So the second scenario, if you perform that experiment and get a wet precipitate, the wet precipitate is soluble in excess, then you know that it is zinc. Zinc is the only ion which forms a wet precipitate, and the precipitate is soluble in excess. Why is it soluble in excess? It is soluble in excess because of the formation of a complex ion. Look at the ionic equation for the formation of a wet precipitate. It is zinc reacting with hydroxide to form zinc hydroxide, which is a wet precipitate. Then the wet precipitate will react with excess ammonia to form this complex salt, which is a cation, plus the hydroxides which will be left in the solution. So this is what we call tetraamine zinc 2 ion, which is a colorless solution. And the ionic equation for the formation of the solution of the wet precipitate is as written on the board. So this is a very important question in the exam, and you must know the formula for the complex ion formed when white precipitate of zinc dissolves in excess ammonia. So this is what we call tetraamine zinc 2 ion. If you get no white precipitate, you add few drops and you add excess, you don't see anything happening. Don't cite no observable change. No observable change is nowadays not accepted in the exam. You write no white precipitate form. And if there is no white precipitate form, you infer the alkali metal, the ions of the alkali metal, that is potassium, sodium, lithium, all the ions of alkaline earth metals, that is calcium or magnesium. So if you don't see any precipitate form, then you infer either potassium or sodium or lithium or calcium or magnesium present. The reason why they don't form what precipitate is that their ions will react with hydroxide to form the hydroxides of the metal which are soluble. Like sodium hydroxide is insoluble in a solution. So you will find a colorless solution formed. So the precipitate is not formed, but the solution, the hydroxides are soluble. So there will be no white precipitate formed. Green, if you add few drops and excess, you get a green precipitate. Then the green precipitate is insoluble in excess. You infer iron 2 ions. Iron 2 ions is the only ion which will form a green precipitate which is insoluble in excess. So it is insoluble in excess because the hydroxide formed will not dissolve in excess ammonia. And this is the ionic equation for the reaction. Iron reacts with hydroxide, forming iron 2 hydroxide, which is a green precipitate, and the precipitate does not dissolve in excess. The last one, the second last, you can get brown precipitate. The brown precipitate is insoluble in excess. Then you infer iron 3 ion present. But at times, you can find that if you get a white precipitate, and after a few minutes, you find the green precipitate forms on the sides of the test tube. That is, you don't infer the iron 3, but you infer iron 2. The reason why it turns brown on the sides of the test tube is that iron 2 is an unstable ion. It always oxidizes to iron 3 in air. It's always oxidized to iron 3 in air. So brown precipitate form, which is insoluble, implies that iron 3 ion present. And it forms a brown precipitate because of the formation of iron 3 hydroxide. So the test solution containing iron 3 reacts with hydroxide, forming iron 3 hydroxide, which is a brown precipitate. The last one, if you get a blue precipitate, copper is always blue. If you get a blue precipitate, soluble in excess. So if it's soluble in excess, it will form deep blue solution. So you talk of blue precipitate, soluble in excess. And immediately it is soluble, you must state the color of the solution. And the color of the solution will be blue precipitate. Why is it dissolving in excess? It dissolves in excess because it will form copper 2 hydroxide. And the copper 2 hydroxide formed will react with excess ammonia, forming a complex salt called tetraamine copper 2 ion. So it is going to form, the reaction will be as follows. The copper in the test solution will react with hydroxide ion to form copper 2 hydroxide, which is a blue precipitate. This is few drops. Then excess, the blue precipitate will react with excess ammonia to form a compound called tetraamine. Tetraamine. Tetra means 4. Tetraamine copper 2 ion, which is a cation, plus the 2 hydroxide, which will be lost from the blue precipitate. So this is what we call tetraamine. Tetraamine copper 2 ion, which is a deep blue solution. This is deep blue solution. So this is the blue precipitate reacting with excess aqueous ammonia, forming this complex salt, which is called tetraamine. And this one is a cation, plus the 2 hydroxide, which have been released by copper. So it forms, it dissolves in excess because of the formation of this complex ion called tetraamine. So copper and zinc are the only 2 cations which form a precipitate which dissolves in excess. So they dissolve in excess because of the formation of complex salt. So the complex salt, when it comes to zinc, is called tetraamine zinc 2 ion, which is colorless solution, and also tetraamine copper 2 ion, which is deep blue solution. So that is how you use ammonia solution to identify the cations in a solution. In our next lesson, we are going to see how you can use sodium hydroxide to identify also the cations. Let us meet in our next lesson. Thank you.